All right, welcome to 15.1 Check on Learning. So I don't think it'll be too bad, so let's get to it. So identify the following statements. This is probably just checking on vocabulary. The terminal side lies in the same quadrant. Select the word from the drop-down list to correctly complete the sentence. The terminal sides of coterminal angles always lie in the same quadrant since they share a terminal side. So I'll agree to that one. The direction of rotation is the same. The direction of rotation is always the same since it is possible to complete multiple rotations in the same direction and is always possible to rotate in opposite directions. I would say is sometimes the same because you can rotate one way and then you can rotate the other way, which would be a negative rotation. The sum of the angle measures is 360 degrees. The sum of the angle measures is would it be always? No. The sum of the angle measures, which ones are they talking about? Go away, face. The angle measures of 0 degrees and 360 are coterminal angles, whose measures sum of 360. But the angles of measures negative 360 and 360 are coterminal angles whose measures sum 0. I think so. Let's check our work on this one. So always is what we got. Sometimes is what we got. That was the positive and negative one. And then sometimes, I think, yeah, okay, I'll agree with that. Because it gave us an example of when it was 360 and then when it wasn't 360. So what is the relationship between the radius of a circle centered at the origin and the length of the arc intercepted by a central angle? What is the relationship between the radius? I gotta draw this out. So the radius of the circle centered at the origin and the length of the arc intercepted by the central angle. So the longer the radius, the shorter the length of the intercepted arc. That's false. The longer the radius, the longer the length of the intercepted arc. Also, the length of the intercepted arc has the same proportion to the circumference of the circle, 2 pi r, as the central angle has the full rotation. I like that one. Let's check that real quick. Oh no, that's what I get for not reading all of them. Oops. The longer the radius, the longer the length of the intercepted arc. Also, the length of the intercepted arc has the same proportion as the area of the shorter the radius, the longer the length. No. So actually, I think they do match. The longer the radius, the longer the length of the intercepted arc. Also, there is a proportion of 2 pi r. Yeah, so that is the one I picked. Again, reading. It's a really great thing. Oh, good. We can do some math. What is the radian measure for the central angle of 180? If you don't know that off the top of your head, you can find it by using, oh look, they give us a pi thing. By using our conversion rate. So 1 pi over 180 degrees equals pi. That one I'm pretty sure about, but just in case you don't believe me. Last but not least, the minute hand of a clock is 4 inches long. The hour hand is 3.5 inches long. What is the distance traveled by the tip of the hour hand and the tip of the minute hand each hour. Enter the correct values in the box. So it looks like they do a lot of the work for us. So the minute hand is 1 revolution per hour times 2 pi r is our inches long. So then they probably want a decimal point there. Maybe not. I don't know. Let me check. Nope, they want us to keep it in pi. So we'll keep pi in there. So this is going to be 8 pi. Again, I'm just looking at this math right here. So that cancels out. 2 pi times 4 inches is going to be 8 pi inches. And then 2 times 3.5 here is what? 6, 7? Yeah, 7 pi, I should say. Oh no, 7 pi divided by 12. Ah. 7. And is that what they got? 7 pi over 12. Oh, there's another one. What is the distance traveled by the tip of the hour hand and the tip of the minute hand each hour? Enter the correct value. So the tip of the minute hand travels blank inches further than the tip of the hour hand each hour. So we need to figure out, so the tip of the minute hand, so we've got our minute hand right here, so we're just going to take 8 pi minus 7 over 12 pi equals, or is it? Round answers to nearest tenth, so that is good to know. So we're going to plug this stuff into our calculator because we have to add the pi's in anyway. So here we go, 8 pi minus, well, let's do some parentheses. 7 divided by 12 pi equals, I can't read the equal button, 23.3. And they said the nearest tenth, right? The nearest tenth. So it travels 23.3 inches further. Bam, 23.3. 23.3 inches further than the tip of the hour hand. So again, if you imagine a clock, you've got your short hour hand and your long minute hand. The long minute hand travels, it travels faster. Every hour it does a full rotation. And the small hour hand just goes boop every hour. So there you go. Not terrible, I hope. But if you have any questions, of course, I will see you in class.